Alright, we're looking at problem number 65. This is in Chapter 2, Edition 8. In a woman's race, 100-meter race, accelerating uniformly, Laura takes 2 seconds and Helene takes 3 seconds to attain their maximum speeds, which they each maintain for the rest of the race. They cross the finish line simultaneously, both setting a world record of 10.4 seconds. A. What is the acceleration of each sprinter? B. What are their respective maximum speeds? C. Which sprinter is ahead at the 6-second mark, and by how much? And D. What is the maximum distance by which Helene is behind Laura, and at what time does that occur? The first question I ask is, how would we describe the motion of each sprinter? Pause the video for just a minute and write down how you would describe the motion of each sprinter. The next question to ask is it possible to describe the motion by one equation for the whole time the sprint occurs? Pause the video and write down your answer. If not, how would you break the motion up into what kind of phases or segments or descriptions? Again, write your answer down and pause the video and write your answer. We can describe the motion in 2 phases. An acceleration phase described by the equation x equal to x initial plus some initial velocity t times t plus 1/2 the acceleration times t squared. And of course, in this case, we're assuming that v initial is equal to 0 and the initial position is equal to 0. So I can write the equation down as x during the acceleration phase equal to 1/2 a t squared. When the sprinter reaches maximum velocity or a constant velocity, I now have a constant velocity phase, and I can write that down as x at any time during the constant velocity phase equal to xa, the position reached during the constant acceleration phase, plus whatever the maximum velocity is, times the time through which the constant velocity phase occurred, and that would be some time minus the time of the acceleration phase. And where we have denoted that Ta equals acceleration time. Now, what do we know? Pause the video and write down what it is we know about the problem. Okay, we know the following. We know the time of acceleration, we know the final time, we know the initial distance, and We know these for each runner. What are our unknowns? Pause the video and write down what the unknowns are. We know that we need to find the acceleration for each runner. We need to find the distance traveled during the acceleration phase for each runner. And we need to find the maximum velocity for each runner. Now we've identified two relations, the acceleration phase relation and the constant velocity phase relation. Yet we have three unknowns. We do not know A, we do not know Vmax, and we do not know the position at which the constant velocity phase occurs, XA. So that's three unknowns. We need a third relation. Is there a third relation we have between the unknowns? Pause the video and write down your answer. There is a relation between the acceleration and the maximum velocity. Pause the video and write down your answer. That equation is the maximum velocity obtained will be equal to the initial velocity plus the acceleration times the acceleration phase. Of course, we start with that equal to 0, and we have that simply equal to A times the time of the acceleration. Do we now have enough to solve for the acceleration? Pause the video and write your answer down. Okay. We do have enough to solve for the answer. Now let's consider the runners, Laura, or one of the runners, Laura. What are the three equations that describe her motion? Pause the video and write down your answer. Okay, for Laura. We have XA equal to 1/2 the acceleration times the time of acceleration squared. We also have X final, or the final position, equal to the position after the acceleration phase plus Vmax times the time through which the constant velocity was attained, and that would be T final minus T acceleration phase. Of course, we know T final is equal to 10.4 seconds, and we know TA is equal to 2.0 seconds. Can we now and we have one other equation that says that Vmax equal to A TF minus, whoops, sorry about that, ATA. Alright, can we solve for the acceleration? pause the video and work it out as to whether you can solve for the acceleration. Try to do it symbolically. Starting with the second equation, xf equal, well, we can substitute for xa over here. I can substitute down here. So I now have 1/2 a ta squared. And then we have Vmax, but then I can substitute up here for Vmax. So that's going to be ATA times TF minus TA. Now we have an equation that the only unknown is A. So we can solve for A. Pause the video. Go ahead and solve for A. Solving for A, we have A equal xf over 1/2 ta squared plus ta times tf minus ta. Now, will this equation work for both runners? Pause the video and write down your answer. Answer to that is yes. All we have to do is substitute the appropriate times. For Laura, we have that A equals 100 meters over 1/2 times 2 squared plus 2 times 10.4 minus 2. And that's going to be equal to 5.32 meters per second squared. Laura. For Helene, A equals 100 meters over 1/2 times 3 squared plus 3 times 10.4 minus 3 seconds. And that's going to be equal to 3.74 meters per second squared. Helene. Part A solved. Now, given the acceleration times and the times through which the acceleration occurred, can we calculate the maximum velocities reached by Laura and Helene? Pause the video and do the calculation. For Lauren, we have that Vmax will be equal to acceleration times the acceleration phase. And that's simply going to be equal to 5.32 meters per second squared times 2 seconds, which is equal to 10.64 meters per second. For Helene, Vmax will be equal to A times the acceleration phase, and that's going to be equal to 3.74 meters per second squared times 3 seconds, and that's going to be equal to 11.22 meters per second. Part B solved. The next part asks which sprinter is ahead at the 6-second mark. And a follow-on question is, what equation describes the motion after the 6-second mark? Pause the video and write down what equation you think describes the position of the runner at the 6-second mark. We can describe it by the equation x equal xa, the position reached during the acceleration phase, plus Vmax times the time minus the acceleration phase time, or the time through which the runner is moving with constant velocity. So let's calculate the position of each runner at the 6-second mark. Pause the video and perform the calculation. For Laura, x equal 1/2 times 5.32 times 2 squared, that's the acceleration phase, plus 10.64 meters per second times 6 seconds minus the acceleration phase time of 2 seconds. And that's going to be equal to 53.2 meter. For Helene, x equal 1/2 times 3.74 meters per second squared times 3 seconds plus 11.22 meters per second times the difference between 6 and 3 seconds, which is the acceleration phase, and that's going to be equal to 50.5 meters. So Helene is behind Laura. Laura is ahead. Part C solved. Now the next question is, how would we find the maximum distance Helene is behind Laura? Pause the video and write down your thoughts. How would we write the equations describing Laura and Helene's motion? Pause the video and write down your thoughts. For Laura, we have, for time less than or equal to 2 seconds, the position is given by 1/2 times 5.32 meters per second squared times the time in seconds squared, which is equal to 2.66 times the time squared. For t greater than 2 seconds, we have that the position is equal to the position that occurred during acceleration plus 10.64 meters per second times t minus 2.0 seconds, the time of acceleration. And xa was equal to 10.64, so x is equal to 10.64 plus 10.64 times t minus 2.0. For Helene, we have t less than or equal to 3 seconds. X will be equal to 1/2 times 3.74 times t squared, which is equal to 1.87 t squared. And for t greater than 3 seconds, we will have x equal to 16.83 plus 11.22 times t minus 3.0 seconds. You should understand where the 16.83 comes from and, of course, what the 3.0 seconds is. Now, what is the importance of the point where Helene's velocity matches Laura? Pause the video and write your answer down. That's the point where Helene begins to close the distance. Can you figure out at what time that point occurs? When does Helene's velocity match Laura's velocity? Pause the video and work it out. That will be the point at which the velocity of Helene will be equal to 10.64 meters per second, which will be equal to 3.74 meters per second squared times time. Solving that, we get obtain t equal to 2.84 seconds. Prior to that time, what is happening? Pause the video and write it down. Prior to that time, Laura is moving away from Helene. Now, can we calculate what the respective positions are at time t equals 2.84? Are you convinced that time t equal to 2.84 seconds is where the maximum distance occurs? So we can now write that for Laura, x equal to xa plus v max times 2.84 minus 2, which is equal to 10.64 plus 10.64 meters per second times 0.84 seconds, and that's equal to 19.6 meter. For Helene, we have x equal to the position gained during the acceleration phase, and it's only during the acceleration phase, so it will be equal to 1/2 a t squared, which will therefore be equal to 1/2 times 3.74 times 2.84 squared, and that will be equal to 15.08 meter. Helene is behind Laura a max of 4.5 meters. Part D solved. End of problem.